Okay, so let's continue with our coding exercise series. So open the leetcode.com and go to the problems tab. And in the search bar, search question number 128. So there is a question number 128, longest consecutive sequence. It's come under the medium category. So click on it. So let's read the question. So longest consecutive sequence given an unsorted array. So we have some arrays given and the name of the array is nums. And these are the integer array and this is unsorted, so it is unsorted order. Okay, so if you see, this is the array is given and all are integers and this is unsorted, which is fine. To return the length, so we need to return the length, so we need to return some integer. So if you see, it's return type on the right hand side, it's integer, and in the argument, whatever the argument is being expected, so nums, which is a list of integer. Fine. So return the length of the longest consecutive elements of sequence. So first we should know what is consecutive elements. So consecutive elements, like the elements which come one after another. Example, 1, 2, 3, 4, 5. So these are the consecutive elements. If 1, 4, 5, so this is not a consecutive elements. Consecutive element means which comes like a counting, which comes one after another. Okay. Okay, you must write an algorithm that runs in O of n time. So they have mentioned you need to write a solution that should run in O of n time. Okay, which is fine. So let's see the example. So we have example 104, 200, 132. So we need to find the consecutive. So let me see. So we have 104. So we have 100. So consecutive means after 100 there should be 101. After 100 there should be 101, right? So after 100 there should be 101, but there is no 101. So if we consider only 100, then length is 1. Okay, now let's take 4. So after 4 there should be 5. There should be 5, but there is no 5. So there is only 1. So 200. So after 200 there should be 201. So there is no 201, so length is 1. So after 1 there should be 2. Yes, 2 exist. After 2 there should be 3. 3 exist. After 3 there should be 4 exist. 4 also exist. So length is 4. So that's why our answer is 4. So these are the unsorted order array. So one thing like you can do is you can just sort the array, because if you sort the array, the array will be 1, 2, 3, 4, 100, 200. Now what you can do is you can just start from any element, from maybe like from the side 2, and you can compare with the previous element. If it is equal, if previous element plus 1 is equal to the current element, then you can increase the current length. Then you can check, as soon as it break the consecutive, then you can find the longest length. So you can do that. But if you sort that, if you sort the array, then sorting algorithm will take O of n log n, but we need to do in O of n. So that's why we can't sort. And along with that, it is mentioned there is an unsorted array. All right, so sorting is not helpful here. Sorting is helpful in solving the problem, but as per the second statement, they said you need to do in O of n. So okay, let's see the second example. So second example is like 0, 3, 2, all this. So after 0 there should be 1. Yes, we have 1. After 1 there should be 2. Yes, we have 2. After 2 there should be 3. So we have 3 as well. Right. So after 3 there should be 4. We have 4 as well. After 4 there should be 5. We have 5 as well. After 5 there should be 6. We have 6 as well. After 6 we have 7. We have 7 as well. After 7 we have 8. And we have 8 as well. So answer is 9. Right. So we have all the elements, because after 3, because if you consider 3, then okay, the length is only this, but from 0 the length is 9. So the answer is 9. Okay. So how we are doing this, because as soon as we, because see, they have mentioned we have to do in O of n time. So O of n time means we have to do in only one for loop, right? So one for loop means only you have to scan like all the elements one by one. Now, as I am explaining, so if we just scanning all the elements using one for loop. So if you pick 100, and now you have to find whether 100 plus 1, that is 101, exists in that list or not. So if you just use the in operator, whether 101 in list, Then in the array or in the list, in operator take of n time. So one for loop for of n, then another in is of n, then it become of n square. Then what we can do, because how we can search like 101, right? So the one thing we can do is we can take the extra space. So instead of list, we can convert into a set. Why we can convert into a set? There are two advantage. Because if there are some duplicates, as an example, there are duplicates. So this duplicate has been removed. That is not a big advantage, but anyhow, like few elements will be reduces, right? Along with that, in the set, now in the set, search operation, or you can say the lookup operation, take O of one. So when we say, okay, if 101 in list, it is taking of n. But if I say if 101 or any element in set, it take O of one. It take O of one. So one for loop for scanning all the elements. And inside the for loop, there is an in operator. There is a if condition, if that element in list, right? So this list or set. So if we say list, then of n, then of n. So this is also O of n. So O of n and O of n square. So that's why we will take a set here. So so if we take set, then search operation is O of one, then total algorithm will run in O of one. But let's see how to do that. So let's take one example. Let's come to the whiteboard. So we have this element, we have this sequence of elements. So what we have to do is, okay, we will start from the 14. So we have 14. Okay, we have 14. So do we have the 15 in the array? So first what we do, we will convert into a set. So we will convert into a set. Okay. And if there are in duplicate elements, it's going to be removed. And why we are converting into a set? So that the in operation will take, or in operation will take like a O of one rather than O of n. And in this question, they did not mention you can't use the extra space, so we can use the extra space. Though they have mentioned we have to use O of n, so that's why we are doing it O of n. Okay, so we will search. Okay, we have 14. Do we have 15? No. So length is 1. And till now, longest length is 1. Okay, now we take 3. So we have 4. Yes, so we have 3. So we have 3. After that, we have 4. Okay, do we have 5? Yes, we have 5 as well. Do we have 6? Yes, we have 6 as well. Do we have 7? No, we don't have 7. So we have length is equal to 4. Okay, what is the maximum length of this and this? So maximum length is 4. So till now the longest length is 4. So let's pick 2. So for 2, do we have 3? Yes, we have 3. Right. So do we have 4? Then till now 6 we have 5. So like length is 5. Right. So till now the longest length is 5. If we pick 5, the what is the next element? 6. Do we have 6? Yes. Right. Do we have 7? No. So till now longest length is 2. Sorry, till now longer length is 5 because 5 is greater than 2. Then we pick 6. Do we have 7? No. Then we pick 11. Do we have 12? No. Then we pick 9. Do we have like 10? No. Then we pick 4. Do we have 5? Yes. 4, 5, 6. Then like length is 3. Then we have 1. We have 1. So do we have 2? Yes, we have 2. Do we have 3? Yes, we have 3. Do we have 4? Yes, we have 4. Sorry. So do we have 4? Yes, we have 4. Do we have 5? Yes, we have 5. Do we have 6? Yes, we have 6. So do we have 7? No. So loops finish. So total length is 6. So the output will be 6. Now come to the 60. Do we have 61? Yes, we have 61. Okay, so length is 2, but 6 is greater than 2. So till now longest length is 6. Now come to 61. Do we have 62? No. So and the end of the array. So we can do that. But if you observe, okay, let's try first this. Then we will try to like optimize this. Let's see, like, because this is the like most efficient solution. And let's see. So what we have to do is we have to scan all the elements. First we have to convert list into set. Okay, so let's do nums of set. So nums is a list. So set of nums. So just convert set into. So how to do the conversion? Just like if we have tuple or set, just type set, right? Okay. So now set has been done. Now what we have to do is so take a longest length, and we can consider it starting as a 0. Along with that, if you observe here, nums length could be 0. So let's take the boundary condition. So we can say if not nums, return 0. If not nums, return 0. So if not nums means that there are no elements, so don't need to go further. Don't need to even convert to empty list into empty set, right? And don't even need to take some variable, right? Then it is going to return because there is a, like they said, nums of length is can be 0 as well. Okay. So now we convert into a set. So now set has been converted. And if there are duplicate elements, duplicate element will be removed because we don't need the duplicate elements. Okay, so the longer last is 0, and we have to do it O of n. So it means one for loop will be run. So for num in num set. Okay, for nums in num set. So what is the current element? Current element is 14. So what is the current number? Current number is equal to num. Okay, what is the current length? Current length is equal to 1, because if we consider 14, if we consider 1 second, if we consider, so for current number is 14. So what is the current length? Current length is 1. Now what we have to do? We have to check if if current number means 14, 14 plus 1 exists in the set or not. All right. And do we need to just do if condition, or do we need to do the while condition? Because we have to continuously check, because if 15 exists, then we have to check whether 16 exists. If 16 exists, then we need to check 17 exists. So we don't need the if condition, we need the while condition. So we will continuously check until our conditions met. So while current number plus 1, current number means 14 plus 1 in which, in set. So this is a set. So this is a set. So this is a set. So in set. So nums of set. If it exists, if it exists, then what we have to do is, so let's suppose 15 exists. So let's suppose 15 exists. Then current number will be 15. So current number will be will be current number is equal to current number plus 1. All right. So and current length will be plus 1 is equal to it will be like basically get increased by 1, and current number also get increased by 1. So now current number is 15. Now we will check, because it will continuously while loop. Now 15 plus 1, 16. Is 16 in the list? If it is exist, then it will again increase our current length to 1. Okay. So if so okay, let's take note 16. So we have current number as a 14. So we have current number as a 14. So we take 14. So current number is 14. Current length is 1. So length is 1, and the longest till now is 0. Then we will come here. Okay, 14 plus 1, 15. 15 is num set. Do we have 15? No. So while loop finish. So we have longest length is 1, but longest variable is 0. So what we have to do is, if there is no condition met, then what we can do is we will assign our longest length is equal to max of longest length and current length. Current length. All right. And then we are going to return longest length. Right, and then we are going to return longest length. So now longest length will be like 1, because it did not went into the while condition. It went into the while condition, but it fails. And then longest length is 0 and current length is 1. So maximum, so longest length is 1. So we have assigned that. Okay. Now we pick 3. So do we have 4? Yes. So current number is 3. So current length is 1. So current length is 1. Then we will check, okay, current number plus 1 in num set. So 3 plus 1, 4 exists. Yes, 4 exists. So we will increase the current length to 1 plus 1, 2. And current number is now 4. So current number is now 4, because we have to check whether 5 exists or not. So now 5 exists. So so if 5 exists, yes. So current length is 2 plus 1, 3. And current number is 5. So then we will check if 6 exists. So like this way we will do that. And at the end we are going to do that. So this is the solution, but we can even more optimize. But let's see like whether the solution has been accepted or not. So let's try to run it. So our sample case has been accepted, which is fine. But did all the test cases has been accepted? So let's try to run it. So it is taking time. Definitely, it's going to fail because of time complexity. Yeah. So as expected, it failed because of time limit exceed. not because the code is wrong, but because the time limit exceed. And 69 test cases pass out of 75. So 6 test cases still failed. So where is the problem? So where is the problem? As I told you, so let me take the example. So if we consider 3, so for 14 we are checking 15. If we consider 3, what we are checking? Do we have 4? Right. Then we are checking, do we have 5? Then we are checking, do we have 6? Okay. But for 2, again we are checking, do we have 3? Do we have 4? Do we have 5? Do we have 6? All right. Then when one number less than current element exists, then why should I check for 3? Because if 2 exist in the sequence, if 2 exist in the sequence, then why should I worry about the 3? Then why should I worry about this? Then why should I take? Because anyhow, if 2 exist, then I will like check that element, right? And if 1 exists, right, then I will check that element. Why should I check 5? Then why should I check 6? Why should I check 2? So what we have to do is, so here for nums in num set, what we have to do is we will put if condition. If num minus 1 in num set, not in, then only we are going to do that. So just to avoid our like unnecessary loops. So if you say we are checking for 3, so for 3 we are checking 3, 4, 5, 6, and we found okay. And let's suppose we have like 100k elements. We check 3, 4, 5, 6, 7, 8, so many elements. We are unnecessarily running while loops. And after that we calculated okay, length is 999, 999, right? And then we have 2. Now we are again checking 2, 3, 4, 5, 6, 7, 8, 9, 9 till like 999, and then we are checking okay, how many number of elements we have now? 1000. So earlier we have 999, now we have 1000 because of just 2. So why in the first instance I check for 3? Unnecessary. I like we are running a loop, right? So that's why we are putting condition. If the previous element, so what we are checking is, so let me do that. What we are checking, if previous element exists, if previous element exists, then we will we will take that element when its turn come, and we are going to skip that current element. So we are on 3. If 2 exists, so if 2 exists, 3 will automatically will cover, 3 will automatically will cover, right? So I am not going to pick 3. So that's why what I did is, if num minus 1 not in num set, so we have 14. So do we have 13 as well in the num set? So no. So that's why we take 14 plus 1, 15. But for 3, do we have 2 in the num set? Yes, we have 2 in the num set. So we are not going to do that. So if 2 doesn't exist in the num set, so it means for 3, we have to take the consecutive sequence, right? So now we have, so that's why like we take. Now if we try to run it, and sample case has been acceptable, let I do something. So now you could say like uh, all the test cases has been accepted. Now it did not fail because of the time issue, because we have removed unnecessary duplication. We have removed this unnecessary duplication. All right, just putting this if condition, just putting this if condition. All right, and definitely it is taking some memory because we are taking some set. We are taking some set. All right, but like the solution has been accepted, and it we did in O of n, because we are running only one loop, and one loop will take O of n. And this is though like in operation, but in operations take O of 1 only. So O of n into O of 1 final is O of n. So that's it. That's the end of the video. Thank you. You can also try this question.